Hi, welcome to lesson 4 of C++ Primer. I'll just bring up Xcode, right? So, in this lesson we're going to discuss the for statement. In a while loop, you have a variable val to control how many times we execute a loop. This behavior happens so often the language defines a second statement, the for statement, that abbreviates code that follows this pattern. A for statement has two parts, a header and a body. The header controls how often the body is executed. The header itself consists of three parts: an init statement, a condition, and an expression. The rules and logic behind how a for statement works will be detailed as we work through some examples. Um, so I'm going to start typing in some code now. I think what I'll do, let's just type in some code. Um, so same as before, hash include IO stream. And by the way, I changed the font size on the editor to make it slightly clearer. But you should be watching this at a desk, really. I mean, you could watch it on mobile, but you won't be able to see the code that way. And obviously, I don't want to put the font size too big because eventually we're going to be showing Editor 4, Unreal Engine 4 code, and we want the C++ primer stuff and the Unreal Engine 4 code to look roughly similar. Right, int sum equals 0, and this time we're using a for instead of a while. Int I equals minus 100 until I is less than or equal to 100 I plus plus. And then inside here we're going to do sum plus equals 1. Oh, we want to add I to it actually. And then outside the body, std cout left the result or I have returned is left sum. Int x equals 0. Oh no, we don't have to do that. We were doing that on the PC using Visual Studio. We no longer have to do that. So Command B to build. We can see that succeeds. Now if we run this, we should, run. In fact, what we need to do is std ::endl just to separate these two down here from each other. Escape, Command B, Command R. We'll see the result I've returned is 0. So what I'll do is I'll explain this a little bit first, and then we'll change some of these numbers in here and see what happens. And you can tell, we can question, you could possibly guess what might happen just before I tell you the answer and stuff like that. So the for statement has two parts, the header and the body. This is the header, and this is the body here. Inside the curly braces, that's the body. The header controls how often the body is executed, that's this part again. The header consists of three parts: an init statement here, a condition, that's this one, and an expression. That's just here. The init statement is int I is minus 100. That defines an int object named I and gives it a value of minus 100. The value I exists only inside the for, and you can't use I after the loop terminates. The init statement is executed only once on entry into the for. The condition I is less than 100, less than or equal to 100, compares the current value in I to 100. The condition is tested each time through the loop. As long as val is less than or equal to 100, we execute the for body. And the expression is this part here. Remember, it's init statement or initialization, condition, and expression. So the expression highlighted there is executed after the for body. Here, the expression plus. In fact, that is supposed to be. How did I do it? I actually wrote plus I like that. So plus I uses the prefix increment operator, which adds 1 to the value of I. After executing the expression, the for retests the condition. So it retests it. If the value of I is less than or equal to 100, then the loop body is executed again. After executing the body, I is incremented again. The loop continues until the condition fails. In this loop, the for body performs the summation, sum plus equals I. That's this part here. What does this loop do? What is the final value of I? That's the question that we need to ask. What does this loop do, and what is the final value of I? So we'll play with editing this code and changing a few values, and I'll explain as we go what's going on. So int I is initialized to minus 100. So the first time through the loop, I is minus 100. And here we're assigning I, which is minus 100, to what's in sum. So the first time through the loop, sum equals minus 100. And then it equals minus 99. So you're literally adding minus 100 to minus 99 to minus 98 to minus 97 over and over and over. And eventually, because you're using this prefix increment operator here, and adding 1 each time, eventually it gets to 0, and then it goes above 100. So you get effectively, we all know that a plus and a minus together is a minus. So minus 100, minus 99, minus 98, this huge negative number. But because after that we're going above 0 all the way up to 100, we're effectively doing at the end of this long string of sums, plus 1, plus 2, plus 3, plus 4, plus 5, all the way up to 100. So all the negatives cancel out all the positives, and that's why you have result is returned as 0 there. So we've balanced the books. But let's say if I change the value of I, the value of this integer here to be 101. What do you think that'll do? Well, just think to yourself what that might do. I can pretty much tell you. Because all the numbers from minus 100 up to 0 cancel out all the numbers from 1 up to 100. 101 added on after the fact. The number returned will be 101. So we'll do that. Command B to build and Command R to run. So it's 101. So you might be thinking, oh well, that's the same as what's written here. That's a bit silly. What happens if we change it to 102? Well, it's not going to be just like 1 and 2. It's going to be literally 101 plus 102, which we all know is 203. So let's Command B, Command R, 103. Sorry, 203. Now change this to 103. We've got 101 plus 102 plus 103, which is 306. Command R. 306. Right. I think we can all see what this code's doing now. What we're going to do next is look at how the code from some older examples compare to each other and how the while compares to the for. What's the difference in the way it looks? Right. For that, I need to go to pull up some code, so just be a second. 1.13a main. Right. Command A, delete. In fact, I'm going to back up there. We want to keep main as is, but we'll just delete this stuff out, I think. Right, and this time we're going to look at a for and a while. Some val. Right. This time we're looking at the sum of 50 to 100 is. So we'll start by int sum to. This is just the way the code's written because I wrote it before. I equals 50. I is less than or equal to 100. I plus plus. And then inside here, sum 2 plus equals I. Now std cout left the sum of 50 to 100 is because that sum 2 left std endl. Now, don't know why that's not building. Let's just do Command B. Reference to overload function could not be resolved. Did you mean to call it? std cout std endl. Where it is, this std doesn't seem to be highlighted as part of the standard namespace, but we're already including IOStream. Overloaded function. For I equals 50 to I is less than or equal to 100 I plus plus. I can't believe that. There's just a missing L there. Right, Command B to build. That succeeds. Now, this is going to sum the numbers from 50 to 100. That's pretty simple. I think it's 38 something or other. 3825. And what we're going to do, just to show the difference, is see how that compares to, like we used a for loop there. How would we do that with a while loop? So with a while loop, we did int sum equals 0, comma, and val equals 50, while val is less than or equal to 100. Curly braces, sum plus equals val plus plus val and then we're going to copy some code here, just this line, because it only needs to be changed slightly. And the way we're going to change it is we're not using sum2, we're just using sum, like that. Right? And this should produce exactly the same result as before. I don't know why the font on that is smaller. Is it? Seems to be. Command R. 3825 twice over. So that's the difference. The for has got this init statement condition, the init statement here, the condition, and the expression. And this while is very similar, but it's a little bit different because here the condition is testing whether it's less than or equal to 100, but that's done in the while loop, so the condition's in the while there. But this part here, the body of it, is this bit here where the value that's stored in val is added onto sum. So literally 50 plus 51 plus 52. So just to explain this while loop, because we've already done the for, the first time around val is already set to 50. So is 50 less than 1 or equal to 100? The answer to that is true, yes it is. So we come into the body of the while, and 50, which is a number stored in val, is then assigned to what's in sum, but it's addition and assignment. So like next plus plus is added to val, which takes val to 51, and then 51 is still less than or equal to 100. So the value stored in sum is now 50, and the value stored in val this time around is 51. So 51 is added on to 50 and then assigned back into sum. So the sum you get is very similar to the for loop. 50 plus 51 plus 52 plus 53 all the way up to 100. And the answer for that is 3825. And that's how calculators are programmed using C++ programming language, or sometimes they use different languages, but that would be like an example of some sort of factorial function there, using loops. Next, so we've compared and contrasted the loops for the for and the while. Advantages and disadvantages to using either form. Well, The difference is, I guess the biggest difference is that you don't have to initialize the um, you don't have to have the init statement outside of the body of the for here. The init statement's inside the body, whereas here the init statement's outside. And the condition, the I++ bit up here inside the body of the for, is actually done. It's inside the header of the for, but here I'm using the wrong terms there. This is the header of the while, pretty much, and the condition is inside the header here. That's true, but the initialization isn't inside the header in the while. It's up here. Um, so and the expression where you're actually modifying the what's in val is done inside the body. So I think the for loop is a much cleaner way of doing things, but while is definitely very handy and they're all useful. I think it's just a matter of preference. Which method do you prefer? You can only see what you like to do as you write more and more code, really. So next of all, we're going to look at problems with the compilers. So I'm just going to bring up some code. Just wait a second. Right, here we go. Part of the compiler's job is to look for errors in the program text. A compiler cannot detect whether a program does what its author intends, but it can detect errors in the form of the program. Common kinds of errors a compiler will detect are syntax errors, type errors, declaration errors, and stuff like that. Always makes me laugh. Things like that cannot detect whether a program does what its author intends. Well, what the author intends is always to make some awesome video game software that enables you to get very rich and become minted. And computers don't always do that. You can't just type in "Hello World" and be a millionaire. Unfortunately, it takes thousands of hours over 30 years to build something decent. But that's just a little side joke. So let's have a look at syntax errors. The programmer has made a grammatical error in C++ language. Highlight the code. I'm going to highlight some of the code from the book here, and the errors it produces. So let's just have a look. This is a book that I've got to help me do this. In fact, I'm just going to back up, Command Z to back up a bit so that I don't have to type in IO stream and everything like that. Just leave the main function there and just delete this like that. And back up. There we go. Let's see the C out. Left. Read each file. Left, std, and L. Right, now Command B on that, and that's a syntax error. An error in the it's a grammatical error in the C++ language, and it says, it gives you a warning here. Let me just change something. I'm not sure why this is happening, but before I went into preferences, and brought up the plain text. The font is set to 14. Must be slightly bigger. Let's see if we can change it again. What happens if we put that up to 18? It's a little bit nicer, but then the colons are all mismatched. I really don't know what's the best way of setting this editor up to make this code look good. But it says it expects a colon after the expression, so this is the expression here. Sorry, semicolon. That's the comma with the dot above it. So we can change that and just put the colon, semicolon in there instead. Command B to build, and that's build succeeded. Could do with getting the fonts looking right on this editor. Next, well, we'll just put a comment in for that, and we'll put error missing quotes around string literal. No, sorry, I'm just copying code, but I'm doing it wrong. Where we put used colon. That's the next one, not a semicolon after NL. Now let's write another one. There were just 3 of these. See if you can spot, or think you can spot, what the error is and how to correct it before I type in update master std NL. Well, I've already just told you what the error is there. So what we'll do is we'll do command B and see what it says. Expected thingy after expression, but it's given this number 4, so let's just use of undeclared identifier update, expected identifier ID, use of undeclared identifier master. So it's basically saying, look, we've got no idea what you're trying to do there. There could be a number of things. It's just trying to prompt you with different ways of correcting it. And I wrote this out before. Missing, quotes around string literal. And all we have to do there is put some double quotes over that, and this time it'll say build succeeded. Next, std cout write new master std NL. And this time it is an error because you can see this has popped up just to warn you, but you just think about what that is. Whoops, oh, I got a message. And missing colon on return statement. But sorry, I'm giving you the wrong one again there. That's the next one. Oh, so you already know all the answers. Second, output operator is missing. Yep, and that's these things here. So we just put them in, and Bob's your teapot. Command B, build succeeded. Now, return 0. and the error on that is missing colon on return statement. Yep, so we'll do command B to show the error, missing colon after return statement, yes. So add that in, command B, and it builds succeeds. So that's syntax errors. There's a couple more things I want to look at before the end of the video. I'll just see we're on 30 minutes already. Alright, so next is type errors. Each item of data in C++ has an associated type. The value 10, for example, has a type of int. The word hello, including the double quotation marks, is a string literal. One example of a type error is passing a string literal to a function that expects an int argument. I'll show that kind of thing later. I'll show the difference between assigning a string to an int and the error. So I'll do that now. Let's say we've got an int I, and we want to assign a string of hello world, like that. Command B. Cannot initialize a variable of type int with an L value of type const char 13. That's a string. So let's just test something. We'll change the type of I to std string and see how it compiles. So assigning a string to an int doesn't work, but if we leave that I there and we put std string here, we'll see command B build succeeded. Alright, that's an example. Code will never be executed, another warning, because we literally do nothing with it. That's because the return value is put there, so that'll go away if we paste it there instead. Command B. Right. Right. And then we've got declaration errors. Every name used in a C++ program must be declared before it's used. Failure to declare a name usually results in an error message. Two most common declaration errors are forgetting to use std : for a name from the library and misspelling the name of an identifier. std : right. I'll use some examples from my notes here. Right, so let's just write some more code. I'll just delete this. No, yeah, because I want to be able to show it. Int v1 equals 0, comma v2 equals 0, std cin, right, v2 no, in fact we've got two values, two variables, v1 and v2. Now if we just type C out, v1 plus v2 std and L, like that, and put some more interesting numbers in, like 6 and 7. I really need to think about this fonts thing, because the numbers look so mismatched with everything else. Oh well, it's only one little bit of less, and like probably nobody even watches it anyway. It's just interesting to make them. Right, so Command B on that, we get Bill fail, but we're just pointing out declaration errors, because we declared forgetting to use std : for a name from a library and misspelling the name of the identifier. So std : Command B, will succeeded, Command R, and we get 13 because 6 and 7 is 13. Right, so error messages, just to sum it up, usually contain a line number and a brief description of what the compiler believes we have done wrong. It's good practice to correct errors in the sequence they are reported. Some errors can have cascading effect and create a lot of new ones. Better to compile the code after each fix. This cycle is known as edit, compile, debug. So you edit, you change some stuff, you compile, Command B, it failed, so you get an error. So what is that error? Command B, edit. So you're now debugging, you're typing in the fix, which is this, that's debug, then same again, that's debug, edit, compile, build succeeded, and there's no bugs now. But debugging can be kind of an alias word for well, if a program's not doing what you want it to, you just add more code and you're just debugging all your life until you get what you want, which is hopefully a very fancy game that makes you loads of money. To be fair. Right. That's it for this lesson. We're now at 38 minutes. Okay. Thank you. Bye.